Pooktree, a tree shaping process invented by a pair of Australian artists, is a little bit weird to say at least. Using living trees as their canvas, they've created some mind-blowing and even useful sculptures. Amazon rainforest is huge. If it was a country, it would rank 7th in size because its surface area is 5.5 million square kilometers. In 2013, a study was published that estimated that there are more or less 400 billion trees in it. That's a lot of trees, or is it? Trees are made mostly of carbon and oxygen. The process by which trees are built is both insane and beautiful at the same time. As we all know, trees produce oxygen that we breathe, but not all of it. Cyanobacteria and green algae produce about 70% of free oxygen in our atmosphere, and trees and other terrestrial plants the other 30%. So trees don't produce all the oxygen that we breathe, but they produce a lot of it. Because of photosynthesis, we can safely say that almost all life on Earth is indirectly fusion powered. Using the power of our sun, plants produce oxygen and they build themselves. And we use that oxygen and we eat those plants, or we eat animals that ate those plants. So yeah. As Veretasium pointed out in this mind-blowing video, trees are not made from the stuff they get from the ground. In other words, most of the mass that trees have did not come from the soil. It came from the air. Trees take CO2 from the air and break it apart. They take the carbon part to build branches and trunk, but they need energy to do so, and that energy comes from the sun. What this means is something astounding. Carbon loves being with oxygen, but it can't anymore. They don't have enough energy to bond together again. Since humans discovered fire 100,000 years ago, we used wood almost exclusively for it. When you take your lighter under a piece of wood, you heat it up, or in other words, you give energy to the carbon atoms in the wood. And if you hold your lighter long enough, those atoms will have enough energy to bond with the oxygen again. They will snap together, so to say. And when they do, that snapping or bonding will release some energy. That energy will go to the other carbon atoms and they too will snap with the oxygen together. They now have enough energy to self-sustain this bonding process. And you can take away your lighter because you just started a fire. In other words, since trees use the power of our sun to build themselves, we can say that a bonfire is just a release of a stored sunlight. So as you can see, fire is just super fast oxidation, and rusting is too, however a lot slower. So in a sense, rusting is just a slow fire. Think about this next time you see rust. Fire tetrahedron gives us a neat way to understand fire. We need heat, oxygen and fuel to start a chain reaction. Remove any of these parts and you can't have a fire. This is why we can blow out the fire. Even though we are putting more oxygen into the fire, we are removing the heat faster than it can be created, thus extinguishing the flame. Paper is awesome. Created almost 2 centuries ago in China, it quickly became one of the most influential inventions ever. But paper is thin. Thickness varies between different types, but we can say that the average thickness is around 1/10 of a millimeter. However, you can't fold a piece of paper in half more than 8 times. It's a myth that Brittany Gallivan, a then high school student, decided to break by calculating the problem and then folding a single piece of paper 12 times. Making more folds is hard, but not impossible. But what if we were to fold a single piece of paper in half 50 times? If we use that the average thickness is around 1/10 of a millimeter, the thickness of the final paper after the 50th fold will be more than 100 million kilometers. That's more than the distance from the Earth to the Moon and back down to the Earth, 150 times that distance. This is the power of exponential growth, and this is the end of this video. Thank you for watching and please subscribe if you like this video. But no matter when it goes supernova, it will be one of the most spectacular events that our astronomers have ever observed. In less than a few seconds, the whole star will shrink down and collapse in on itself, creating mind-blowing pressures, and then it will explode.